Welcome to the Explainer. Think about the last call you took in a moving car. How it felt so seamless, right? Almost like magic. Well, today, we're pulling back the curtain on the invisible network that makes that magic happen. It's an incredible, complex dance, all designed to keep you connected.
I mean, you've definitely thought about this before, probably while you're cruising down the highway or sitting on a train. How does your call stay so perfectly clear while you're moving at high speed? And how in the world does the network always seem to know exactly where to find your phone?
So, the secret isn't some giant, all-powerful antenna covering the entire country. The reality is actually way smarter and way more elegant. It's an invisible, intelligent grid of smaller zones that blankets the world around us.
At the very heart of this system is this beautiful, simple idea called cellular telephony. See, instead of one massive tower trying to cover an entire city, the network divides the area up into lots of these smaller regions, or cells. This simple act of division is the key that allows millions of us to use our phones all at once, without the whole thing collapsing.
The easiest way to picture this is to imagine the world is covered by a giant invisible honeycomb. Each of those little hexagonal shapes is a cell, and right in the middle of each one, it has its own antenna. This honeycomb structure is the foundation that makes everything else possible. It's how the network can provide such efficient and seamless coverage.
Now, to really understand how this network operates, you just need to know the three main players. First, there's your phone, which is technically called the mobile station, or MS. Second, you've got the tower and antenna in your cell. That's the base station, or BS. And finally, the most important piece of the puzzle, the mobile switching center, or MSC. You can think of the MSC as the network's brain, or maybe its air traffic controller. It's the thing that coordinates the whole show.
Okay, so this cellular grid solves a huge problem, which is that there's a very limited amount of radio spectrum to go around. The solution is this incredibly clever trick called frequency reuse. It means the network can use the exact same frequencies in different cells, just as long as those cells aren't right next to each other. This prevents interference and dramatically increases how many people can use the network. And here's how that works in practice. To avoid that interference, neighboring cells can never use the same set of frequencies. So what engineers do is group cells into these clusters, let's say a cluster of 7, and each cell within that cluster gets a unique set of frequencies. Once you have that 7-cell pattern, you can just repeat it over and over again, kind of like tiling a floor. It's a brilliant way to cover a huge area and serve millions of people with a very limited number of radio channels.
So now we've got the grid, and we have a smart way to handle the frequencies. Let's put it all together and trace the incredible journey of a single phone call as it moves through this invisible network.
The second you hit that send button, this super fast sequence kicks off. Your phone immediately finds the strongest local base station and sends out its request. That station then shoots your request up the chain to the MSC, the network's brain. And the MSC instantly finds a free voice channel for you and connects the call. This whole 4-step dance happens in the blink of an eye, every single time.
Now, receiving a call is honestly even more interesting. When a call for you comes into the MSC, the network doesn't actually know which cell you're in, so it broadcasts something called a page across all its cells at once. It's kind of like a town crier shouting your phone's name. Your phone hears this page, raises its hand, and reports its location back to the MSC. Only then does your phone actually ring, now that it's been found in this huge sea of users.
And that all works perfectly if you're standing still. But what about when you're moving? What happens when you cross that invisible border from one cell into another one? Well, this brings us right back to our original question and to the most critical, most amazing part of the entire system.
The answer is called the handoff. As your signal to your current cell gets weaker, the MSC is already watching. It sees that a stronger signal is coming from the cell you're moving into, so it orchestrates this completely seamless transfer. The best way to think about it is like a relay race. Your conversation is the baton, and the cell towers are the runners, passing it flawlessly from one to the next.
And there are two ways to pass that baton. Older networks used what's called a hard handoff. It was a break-then-make system. Your phone would literally drop the connection to the old cell before it grabbed onto the new one, which is why you sometimes heard a little click or a brief interruption. But today's systems use a much smarter soft handoff. It's make-then-break. Your phone connects to the new cell before it lets go of the old one. For a split second, it's connected to both. And that's the secret to why your call feels perfectly continuous. This elegant system of cells and handoffs didn't just appear out of nowhere. It's really the product of a decades-long evolution that took place across several generations of wireless technology.
The journey started back in the 80s with 1G. That was the era of analog brick phones and pretty crackly voice calls. Then, the 90s brought us the 2G digital revolution. This gave us much clearer voice calls and a brand new superpower, SMS text messaging. Then, in the 2000s, 3G came along and it unleashed the mobile internet. So in just about 2 decades, we went from a phone in a car to the internet in our pocket.
And the really key thing to understand here is that each generation's technology enabled a new killer app. 1G's analog tech was just about making mobile voice calls possible. 2G's digital tech was more efficient, so we got secure calls and, of course, texting. But 3G's WCDMA technology was the real leap. It started treating data like internet traffic, and that paved the way for the true mobile web. The technology always defines the application.
And 3G's killer app was all about one thing: speed. The target was 2 megabits per second. Now, that number might sound tiny today, but at the time, it was a total game changer. That was the magic threshold, the speed needed to finally make mobile broadband a reality. It opened the door for everything from online maps to the very first video streams on a phone.
So, in just a few decades, this incredible system evolved from handling simple voice calls to becoming a global, high-speed network that lives in our pockets. It's a grid built on simple ideas that together create something astoundingly complex. Which really just leaves us with one final question to chew on. As we push towards a future of augmented reality, of instant, constant communication, what's the next great challenge for this invisible grid that connects us all?